subtracting complex and things of fractions. So when you add and subtract fractions, what do you have to have?
Common denominator.
You have to have a common denominator. Okay. So just like when you did with integers, you had 2/3 plus 1/2, you had to figure out some common denominator between the two. And usually that wasn't so terrible. You figured out what the least common denominator was, or the next common multiple. What's the next number that 2 and 3 both go into? 6s. So we changed the 2/3 into something over 6. We changed the other one into something over 6. 3 times what is 6? 2. So 2 times 2 is? 2 times what is 6? 3 times 1 is? And you got 7/6. That was how you worked with common denominators with numbers. Gee, what do you think is going to change when you have all this fun stuff? Not a whole lot. Not a whole lot. So if I look at this first one, I have 4 over 3x plus 5 over 3x. Do I have a common denominator?
Yeah.
Yes. What is it?
3x.
3x. So now, since that's the common denominator, what's 4 plus 5? 9. Am I allowed to simplify that fraction?
Yes.
Yes, because it's a monomial. Since there's no addition there, I can simplify that as a regular old monomial. The 9 and 3 becomes 3 over 1, otherwise known as, and you're done. Not too crazy. The same deal goes for on the other one. I have a common denominator right away of x plus 3. Since that's already common, I just rewrite it. I'm sorry, guys.
It's okay, we all die
And then I just write out 2x minus 4.
Did you see that look he gave you?
I get it.
Why is everybody laughing?
Because he's saying I'm going to die because I'm coughing. And then can I simplify that any further? Is it going to get you anywhere? No. But it doesn't help any. You can't simplify any x's or anything like that. You're done. And this is the case of when you don't have the monomial, you can't do anything else. There will be times that you could simplify. There will be times you can simplify things further and going from there. But it's not always this clean. So why would it be? That would be too easy. Sometimes it's going to be nasty. Sometimes it might look like
Was the
this.
answer 2x minus 4 over x plus 2?
Yeah. Sometimes we'll get something like this, where we have 5 over 6x squared plus x over 4x squared minus 12x. And I need to figure out some, you remember what the LCD stands for? Not liquid crystal display. That was supposed to be funny.
Oh.
Thanks. Sure, kick a guy when he's down. Thanks, guys. Remember, when you go through these, what you want to do first off is try to factor things out, simplify things through, and see what you can get. In the first fraction, is there anything I can do here?
You can factor the 4x squared minus 12x.
On the second fraction, yeah, that's what I was getting at. The first one I can't do anything. But the other one I have the x, and I can take out a 4x, and I have an x minus 3. Are we okay with that? Now, in that secondary fraction, is there anything else I can do now? I can take the x out. The reason I can take that x out is because it's a monomial. Remember, a monomial is a bunch of numbers put together with multiplication. There's no, I've got terms. Okay? It's 4x times the x minus 3. The numerator, the x. So these x's basically they simplify out as a term of 1. So now you have 6x squared plus 1 over 4 times x minus 3. And, excuse me. So now you start thinking of it in terms of common denominator. Always go with your numbers first. What's the next number that both a 6 and a 4 go into? 12. Good. So I know that my new denominator is going to have a 12. Now over here I have this x squared. On this side I don't, but this side I have the x minus 3. Everybody okay with what I'm doing there? I'm just piecemealing it apart. What parts do they share? What parts don't they have? So now it's just a matter of, well, the fraction on the left, how do I turn a 6 into a 12? What do I multiply it by? 2. So it'll be a 5 times 2. And then I have to multiply it by the x minus 3, because it didn't have that. And then the other side, how do you turn a 4 into a 12? Times 3, so it'll be 1 times 3. It had the x minus 3, but it needs the x squared. You're going to do a lot of what doesn't it have, what does it need to make it go through. That's the easiest way to turn these things into common denominators. Do not worry about multiplying out your denominators. You can leave them as terms, but I do want you to multiply out and simplify the numerators. Okay? So the numerator, excuse me, I'm going to get 10 times the x minus 3 gives me 10x minus 30 plus 3x squared. Everybody all right with that? When I rewrite this, my final answer then would be 3x squared plus 10x minus 30 all over 12x squared and x minus 3. And you sit there and think about it, what times what's negative 90 that you add together to get 10? I think that it factors itself through. It's 90. We got 190, 245, 3, 30, 4, no, 5 and 18, 6, no, 7, 9 and 10. Yeah, so there's no combinations that'll get you to the 10th, so don't worry. That's it. Every once in a while, you might find something that simplifies further, and the reason that is because you might have not used the least common denominator. You might have used too great of a common denominator, and that does occur. Yes, ma'am?
Hey, where did the 2 come from? Was it I know numerator.
How do I turn the 6 into a 12? I multiply it by 2. So basically what I'm doing, I'm multiplying by all these deals of 1.
Why turn it into
Common denominator.
20?
Between the 6 and the 4.
Gotcha.
What I'm doing here is a shortcut version of multiplying out by all those values of 1 by not writing this. Because x minus 3 over x minus 3 is 1. 2 over 2 is 1. Just by simplifying through. What changes do you think happened with subtraction? Nothing. So before you go and write all of that out, remember, when you're trying to find common denominators, you're going to factor your denominators. You always want to factor the problem, just like you did with multiplying and dividing, because that's an easy way to figure out if something simplifies through. So as I write this problem down, what I would do is I'd write down x plus 1 over, well, what times what's 4 that you add together to get 4? 2 and 2. So I would be writing this problem down as this: x plus 1 over x plus 2, x plus 2, minus 2 over, well, that's a difference of squares, isn't it? So it has x plus 2, x minus 2. What do those two denominators have in common? They have an x plus 2 in common. So if they have one of them in common, what's left? An x plus 2 and a x minus 2. So by doing this, think of this as prime factoring. When you used common denominators before, if it was a 6 and an 8, you would write that as 2 times 3. And this was a 2 times 2 times 2. What did they have in common? They had 2's in common. What was left? A 3 and 2 more 2's. And that's how you're able to figure out common denominators to the least common by using primes. It's the exact same thing with terms. You do the same thing. Okay. Sorry, excuse me. Excuse me. So, fraction on the left. It had an x plus 2 and an x plus 2. It was missing the x minus 2. Fraction on the right needs another x plus 2. Okay. You'll find out real quick that a lot of these FOIL problems are relatively easy, but I will warn you when you have subtraction. More often than not, that's where you guys will make a mistake, because when you'll forget to distribute the negatives to the secondary terms.
So whatever you flip over on in the denominator, you put numerator too?
Yeah. Since these were both shared, we wrote it down once, and then we just put over the leftover. This one had 2 pluses, it was missing the minus. This one had 1 of each, it was just missing 1 of these. That's all. What is it missing? That's the easiest way to set these things through. So let's see, we have x squared minus 2x plus 1x would be minus x minus 2 minus 2x minus 4 over just write that out. Was it x squared minus 3x minus 6? Remember, don't multiply out the denominators. Just don't. There's no reason. Absolutely no reason to. But could I simplify this just a little bit?
It's an x plus 2 squared.
Yeah. Then that's so. By all means, if you have like multiple terms of junk, write it as junk squared. It's just a little bit easier to write. If you do, either one of these like that or with the square is perfectly fine in my book. I have no problems. Just don't waste your time multiplying out. It doesn't help any at all. Okay. And then obviously you go to your numerator just to double check yourself. What times what is negative 6 that you add together to get negative 3? Nothing. It's gonna make one day. Excuse me. So far, so good. Told you, I slept my window open on Saturday. It was killing me with that stuff.
What?
He's like so proud of himself.
This is a complex fraction. It's a pyramid of evil. It is a pyramid of disdain. Welcome to the Wambulance. I just thought it was funny. So most people complain when they see this. So I say Wambulance. Welcome to the Wambulance. Because I'm an idiot. So this is what we call a complex fraction. A complex fraction is a fraction divided by another fraction. And it's just another way of rewriting, instead of having horizontal math, this is just vertical math. It's the same thing. If you think of it this way, and I'll come back to this problem in 1 second. if I took 2/3 divided by 1/2, that's also a complex fraction. It means the exact same thing as this, which in essence would be this. Okay? It's the exact same scenario. When we get to the complex fraction with the addition and all that, think of it as the same idea. What you wind up with here is you've got fraction divided by another fraction. But in order for us to be able to do that flip and multiply things through, we have to get this in terms of a single fraction. Does that make sense? So in this case, all you need to really worry about is the denominator. So what I want to do here is create the common denominator for 1 over x plus 2 plus 2 over x. And again, in this case, it's pretty quick, because on the left, it has the x plus 2 as a term. On the right, it just has an x. So that means the common would be x and an x plus 2. Now, you'll see me do this a lot with these complex ones, and it's a pretty nice way of doing it. Don't continually rewrite the whole thing. Just work each part independently, and then flip them at the end. So fraction on the left, it has the x plus 2, it needs the x. Fraction on the right has the x, it needs the, okay? Just like the idea of you had the 1/3 plus 2/5. The common would have been a 3 times 5. Fraction on the left needed a 5. Fraction on the right needed a 3. It's the exact same thing, but with monomials as opposed to integers. You do the same process. Okay? So the numerator here becomes x plus 2x plus 4. So it's 3x plus 4 over x times x plus 2. Be okay with that?
Wait.
I distribute, and then I combine my like terms.
Why can't you just cross out the, oh wait, it's good addition.
It's addition, very good. So now I've got this. It's just fun. I have that, so I rewrite it horizontal. I forgot. All I've gone then from is the awful complex fraction to just the horizontal, which was exactly what you did the past 2 days, so it's the same change, flip. And what drops then? The x plus 2's drop, and you get 2x over 3x plus 4. Get it done. What's that? Pretty much. Welcome to math. I know, right? And then pretty soon you'll be doing problems like that on the, simplify, verify. It's great. So it looks awful, but was it really all that awful? Well, everything is for you, so that's okay. We're used to your complaining. Hence the wambulance. I thought the wambulance was funny. You guys didn't like the wambulance?
No, we liked it. It's just we were all still whining because of the problem.
That's
So we didn't appreciate it.
Like nobody like said anything. You're just like, that was supposed to be funny. And it's like, oh.
It was a stretch, I know. All right. Take a minute. simplify that, so you can do it. It's not as complicated as the one we just did. Hey, what is the 4 over that you don't see? And what is the 8 over that you don't see? Are we okay with that so far? Which all I'm going to change is then I'm going to rewrite this as x plus 20 over 5 divided by 8x plus 1 over x. So I get x plus 20 over 5 times x over 8x plus 1. So again, all I remember asking you guys to do is to multiply out numerators. Don't worry about denominators. So you could have just left it as 5, or x squared plus 20x over 5 times the quantity 8x plus 1. Or in this case, it's really fast to multiply out. If you multiply it out and wrote 40x plus 5, it's fine. Okay? That's all it is. Everybody get that all right?
I don't know.
What's that?
I got lazy, I didn't do the x squared.
Yeah, remember, my only rule is always multiply out numerators. Always multiply out your numerators. What's that?
I was gonna say, like, I don't know, like, where to put the addition sign, like, when you're putting it in a numerator from, like,
Well, for this?
yeah,
Well, all right, you're okay with the common denominator being x, right?
yeah.
This one needs the x, this one doesn't. So it's the plus between the two terms. It'll always be between the two terms.
Because I know I could put, like, because, like, you need the x times the 1 to get it in the denominator.
Yeah.
So I didn't know whether to put, like, plus x, or, like, where to, like, put the x term, like, multiply it by which part of the,
Okay, so this one was over 1, this one was over x.
yeah.
The common is multiply the two together to get x.
Yep.
This needs x. This needs the 1. So that's why it's 8x,
Is it, like, just across them?
pretty much. Because you're multiplying this one by a factor of x over x, and you're multiplying this one by 1 over 1. That's what you're doing to generate. This wasn't the numbers though. Let me double check the numbers here for you. Let's do this.
Well, that's good, I guess. I haven't studied.
Oh.
Do those.
And then over.
You have it over what? You can multiply that if you want.
Yeah, you don't have to multiply out the denominator. You can just leave it as terms. Your denominator will always be a bunch of monomials multiplied together. Your numerator will usually have some addition between the two parts. That's why you can combine like terms in the numerator. Denominator doesn't. Alright. Do you guys want me to throw this up on the board for you while it's out there?
That's a lot.
32, 34, 36, 38, 40, 42, 44, 46. I know. That's 8. Yes, this is 8. That's a lot. Hey, don't hate me when you see some of these.
I hate you already. Just go to stuff out.
Ooh. Scared myself from the whammy nuts.
C minus.
Yeah.
Right? Yeah.
I have C minus.
Oh,
It's like it's 16 point something. We rounded.
exciting.
Oh, wait. For
And I apologize for not being as enthusiastic about everything about math today.
We were just guessing about the wind.
Yeah, I would have been really all over that, but had I not felt like absolute poop. But I felt